We're at a point where immersive technologies such as augmented and virtual reality are becoming commonplace in our homes, schools, businesses, and training centers all over the world. The appeal of these technologies lies in their ability to convey learning content in ways that go beyond viewing videos, listening to lectures, or reading textbooks. These technologies encourage active interaction to provide an embodied learning experience. As these technologies begin to flood the market, the desire to utilize them for training applications increases. The challenge that is presented is determining when and where these technologies will be most effective. Ideally, training effectiveness evaluations should be conducted, but as we know, there is often not enough time, money, or resources available to execute them. Further, many of those who oversee acquisition of these technologies may not have a background in learning theories and training research. Therefore, to choose the most effective technology while reducing unintentional wasteful spending, guidance is needed to help those in charge of acquiring new technologies for training to choose the best fit solutions. The current project focuses on developing a technology recommendation support tool for the acquisition workforce. The specific end users for this project are U.S. Navy ACAT 4 acquisition personnel, although this tool can be used by training researchers as well. The goal for this project is to develop a software support tool that guides acquisition personnel through a learning and training perspective, granting them the ability to make evidence-based informed decisions when acquiring technology for training. The tool features a series of questions for the user that focuses on learning objectives, fidelity, collaboration, communication, and environmental factors to help pinpoint the optimal technology recommendations. The work we are presenting here describes some of the challenges we face when designing the tool. These are common challenges faced by many researchers and training designers. Therefore, we wanted to describe what the challenges were and how we overcame them to help others deal with similar issues. The focus here is on ACAT 4 personnel. Very little documentation exists about the process they use to make technology acquisition decisions, making this step strongly dependent on stakeholder input. The other problem is it is very difficult to gain access to these end users. The intent of the tool was reevaluated. Instead of trying to integrate the tool into the current acquisition process, the reconceptualization of the tool was to educate acquisition personnel about the importance of basing technology acquisition decisions on training outcomes. This idea was spawned when we looked at the Defense Acquisition University's course curriculum and realized no courses offered education on training methods or instructional design. The initial framework in ConOps was complex and strongly emphasized the concepts of designing a training device rather than capturing an approach for the acquisition process. Open lines of communication with the internal design team, external development team, and stakeholders supported revision to reflect only the essential training-related components needed to generate the technology recommendation. Sample content was generated to better understand the information that would be presented to the user and how to format it. The knowledge needed to make technology decisions is usually outside the user's training, and that user, an acquisition professional, may be biased toward acquiring a specific technology. An evaluation of the process was conducted using a sample use case to gain an in-depth understanding of the goals to be achieved at each step, and were mapped out and described to show how output in one step would support the input in the next. Extraneous components were identified and either removed or integrated into subsequent steps. Designing the interface for a different user than whom it was originally conceived while maintaining the look and feel of the original solution. Through the iterative design process, a mix of wireframes and mockups were generated and tested internally with the design and development team. Stakeholder feedback was obtained to ensure the support tool aligned with their vision and expectations. With the proper implementation, this support tool will lead to more effective training, which in turn can result in additional cost savings while better preparing trainees for operational tasks.